How much?
45 degrees.
Sorry?
45 degrees.
45 degrees from where? Where do you measure angle from? Where do you measure theta from? How much
The
is
angle of 225.
the angle be how much?
225.
225. Because we always measure our angles from the positive x-axis. Yeah. The other one, 5 meters east. The angle will be how much?
It will be 0.
0 degrees. The other one, 60 degrees north of east. How much is theta? How much is theta? For 60 degrees north of east. You go east, then you go north. You make an angle of 60 degrees. You go east, then you go north. How much is that? What angle is that?
It will be 60.
Yes, it's 260. Okay. So we have our vectors, the sizes of the vectors, with the angles, sizes of the vectors and with angles like that. So let's work out these. Probably we can, yeah, like that. So in our case, how do we work out AX? How do you find AX?
The magnitude of A cos the angle it makes.
Okay, just a minute. I want to modify these angles so that you can differentiate them. So I'm adding a subscript 1, 2, and 3. So the magnitude of A then cos the angle is theta with the 1. There. So A, the size of A times the angle it makes with the x-axis, which is what you have there. So how much is A?
4.
4 degrees. Forward. It's forward. Does it have any units? What is the size of A?
4 meters.
Yes, 4 meters. There. And how much does that give us? 4 meters times cos 225. How much we get? How much we get for this?
Negative 2.82.
Negative 2.8 meters. Okay, there it is. Next, AY. How do we cut AY? How do you find AY?
The magnitude of A sine the angle it makes.
Okay, like that. The magnitude of A is how much?
4 meters.
4 meters. And the angle it makes with the x-axis, positive x, is how much?
225.
225. And how much do you get for that? 4 meters times sine 225?
Negative 2.8 or so.
Negative 2 points?
2.8.
Negative 2.8 also. So you see something here with a vector in the fourth quadrant. You see that in the third quadrant, AX is negative, AY is also negative. That's what happens in this quadrant. Okay. Next, we move on to BX. How do you get BX? BX, how do you get BX?
The magnitude of B cos the angle it makes.
Okay, magnitude of B, that's B. Cos the angle it makes is theta 2. Like that. And what is the magnitude of B?
5 meters.
5 meters. And the angle is how much?
0.
Okay. So there we are. 5 meters times cos 0 is how much?
I found 5.
Yes, because it's 5. Next, how do we work out by?
The magnitude of B sine the angle it makes.
Magnitude of B is an angle it makes. Okay, so here we are. So B sine the angle it makes, and angle we have it there. So next, how much is the magnitude of B? How much is the magnitude of B?
5 meters.
And how much is the angle? And how much is the angle?
0.
0.
0.
Okay, so there we are. 5 meters sine 0. How much do you get for that?
0. 0.
0 meters. So we see here, when it comes to B, B has got an x component, and that x component is 5 meters, which is actually the size of the vector. Because B lies along the positive x-axis, B does not have any y component. The y component of B is actually equals to 0. Is that clear?
Yes.
Okay.
Yes, sir.
Let's move on to C. How do we get Cx? How do you get Cx?
The magnitude of C cos the angle.
Magnitude of C equals the angle. There. C, the magnitude, then cos the angle. How much is the magnitude of C?
meters.
6 meters. And what angle does it make with the positive x-axis?
60 degrees.
60 degrees. Yeah. So how much you get? 6 meters times cos 60 degrees.
3 meters.
3 meters. Okay. Next, we move on to CY. How do we get CY? How do you get CY?
The angle, the magnitude of C sine the angle.
Okay, magnitude of C sine the angle. Like that. Okay, the magnitude of C is how much?
Um, 6 meters.
And the angle is how much?
60.
16. Okay, so there we are. 6 meters times sine 60 degrees. How much is that?
5.2.
5.2. Okay, so for each of our displacements A, we have the x component of A is minus 2.6, minus 2.8. The x component of B is 5 meters. The x component of C is 3 meters. The y component of A is minus 2.8. Y component of B is 0 meters. Y component of C is 5.2 meters. So we need to add the components for us to get the arrow which we have here. This is the resultant. So for us to get the resultant, we need to add A plus B plus C. So we need to get the x component of this guy, the arrow. So write arrow x is equal to that. Then just a minute. Then I'll write RY. Rx is equals to that. I'll write RY equals that. So for us to get Rx, the x component of the resultant, we need to add the x components of these guys which are being added. Ax plus Bx plus Cx. Is that clear? Always. Is that clear? You add the x components together, you add the y components together. Is that clear?
Yes, sir.
Okay, so let's do that. So the x component there is that minus 2.8 plus the other one is 5 meters. Plus the other one is 3 meters. Okay, like that. So basically I think I can try to make things a bit shorter. This side, let me just write arrow. I'll just write arrow like that, so that there's space. So minus 2.8 plus 5 plus 3. How much you get?
5.2.
5.2. Okay. Next. Okay, 5.2. Next we have the y parts minus 2.8 meters plus by is 0 meters plus cy is 5.2 yeah. We seem to be running out of space. Yeah. Okay, so how are we going to do this? Let me see. I need to add a few lines. Just a minute. I need to do a copy and paste bits. But then under there we have a bit error, nothing. Just a minute. Then I need to remove. Need to end up having this. That x is because of that. Then up here I need to have just a minute. This guy. Yeah, I need to remove this. Then down here. Okay. Let's see what you have. Okay. Alright, that seems to work. Okay. Alright, now it fits. Okay, so how much do you have for ROI?
2.4.
2.4. Okay, so now we see something different here from what we have been having. You see the Rx is positive. That is 5.2 meters. So that means Rx lies along the positive x-axis. Then Ry is also positive, 2.4. That means Ry lies along the positive y-axis, meaning that our R, the resultant vector R, actually lies in the first quadrant. Is that clear?
Yes.
Okay. Just a minute, some typing to do. Okay, so on the xy plane, vector R, just a minute. Vector R has an x component which lies along the positive x-axis and the y component which lies along the positive y-axis. Therefore, vector R lies in the first quadrant. In the first quadrant of the xy plane. So if you look at what you've done, I think this. The question says the components of each displacement. Have you seen this? One of the questions? The components of each displacement. Have you seen that?
Yes.
That is the first question. So actually, the first question we have answered it by filling up the table. So AX is minus 2.8, AY is minus 2.8, BX is 5 meters, BY is 0 meters, CX is 3 meters, CY is 5.2 meters. So those are the components of each displacement. Okay, so the first part has been answered. The first part of the question has been answered. Next, number 2, the components of the resultant displacement. The resultant displacement is R. What are the components? It's Rx, and you have found Rx to be 5.2, and Ry, which you have found to be 2.4. So basically, again, question number 2 has been answered. Okay? Is that clear? If we want to be more explicit, I don't know, but you can just go to the table, find for each vector, for each displacement, what are the components. So for AX, that is minus 2, AY, again, is minus 2.8 meters, BX is 5 meters, BY is 0 meters, CX is 3 meters, CY is 5.2 meters. Question number 1A, the first part of the question answered. The resultant, which is our R, the X component of the resultant is 5.2 meters. The Y component is 2.4 meters. So basically, the B part, this part also, number 2 of question 3, has also been answered. So you can get the information from the table. So the only thing really we need to work out is the magnitude and direction of the resultant displacement. We need to work out the size of R and the direction of R. Okay, is that clear?
Yes.
Okay. If people have got questions, they should ask. Okay, so the magnitude of resultant displacements are denoted not. Okay, so we get the magnitude. Just a bit. Where are we? Here. So we're looking for the magnitude R. How do you get the magnitude R? How do you find the magnitude of R?
Sir, is that a question that can be answered, or maybe we should wait from you?
I'm asking you, how do you find the magnitude of R? What do we know about R? We're looking for the magnitude of R. How do we find the magnitude of R? We have a table here with the components of R here. So how do we use those to find the magnitude of R?
Okay.
The Rx squared plus the Ry squared, and then with the squared.
Rx squared plus Ry squared. Is that clear?
Yes, that is correct.
Just a bit. So if you look at the table, so we need Rx and Ry. Then we square them. Just a minute, I'll show the table. You look at the table there. How much is our Rx? How much is Rx?
5.2.
5.2. And how much is ROI?
2.4.
2.4. Down here, there. So we have 5.2 squared plus 2.4 squared, and everything we square root that. What do you get? Use the calculator. Give me the final answer.
5.7.
5.7. Can someone confirm that? Can someone confirm that it's actually 5.7? Okay, 5.7 it is then. Next, since our vector lies in the first quadrant, I'll type something. Since the resultant vector, lies in the first quadrant, then xy plane, we only work out the angle between the vector and the positive x-axis. Vector and the positive x-axis. This angle is measured anti-clockwise, and is denoted theta. Denoted as theta. So in this case, in the first quadrant, you only need to measure one angle, okay, which is the theta. So we know how to do that. Tan theta will be how much? How do you get tan theta?
RY over RX.
Yes, RY over RX. There, RY over RX. What? Just a minute. I must copy something else. So how much is our ROI?
2.4.
2.4. And how much is our RX?
5.2.
5.2. 2.4 meters divided by 5.2 meters. How much is that going to be?
Zero 0.462.
0.46. Okay. Then next we work out the tan, the angle, using say theta will be equals to tan inverse of 0.46. How much is that?
24.8.
How much?
24.8.
24.8. Okay, so we get that as well. Okay. There.
So,
Yes.
when finding the angle theta, there are some textbooks where you have to subtract the angle that you found, 24.8 by 180. I'm just wondering when we're supposed to do that.
We have actually been doing that. So you subtract the, here, if you notice what you're doing here, we are working out theta directly. You do this in the first quadrant. Okay?
So it depends on the quadrant that theta is in.
It depends on the quadrant the vector is in.
So if the resultant vector is in the fourth quadrant, we subtract the angle by 360.
Yes, if it's in the fourth quadrant, you subtract. In the fourth quadrant, like we have done, if you notice, here, we worked out, we didn't work out theta, we worked out this one, phi. And
Yes.
And that's what we found. We found a phi of minus 23. Usually the phi is going to be negative. So for us to get theta, it's going to be 360 degrees plus the negative phi, which gives us a theta of phase. This is what you do in the fourth quadrant. In the second quadrant, and in the third quadrant, in the second quadrant, third quadrant, you use this. However, in the second quadrant, your angle phi is going to be negative. So you end up having 180 plus phi, but your angle phi is negative, so you get this. If you were in the fourth quadrant, sorry, if you were in the third quadrant, as you have seen, we have one of our vectors is in the third quadrant, I think. This one, vector A, this one here, minus 2.8. Minus 2.8. So in the third quadrant, if you divide AY divided by AX, you get a positive number. Then you end up having a positive angle. So in the third quadrant, your angle phi is positive. So if we were in the third quadrant, this phi would have been plus 23. So if you brought it here, it would have been 180 plus 23. Okay? So in the first quadrant, you just do a direct calculation for theta, like we have done here.
By direct calculation, you mean I shouldn't subtract theta by 90?
No, you should not. No, you should not. In the first quadrant, you don't work out phi, because we are using phi to subtract and add. So in the first quadrant, there is no phi being worked out. In the first quadrant. In the second quadrant, you work out phi, then your phi is going to be negative, then you're going to add it to 180. So 180 plus a negative angle will give you an angle which is less than 180. In the third quadrant, your phi is going to be positive. So you end up having 180 plus phi, which is positive. It will give you an angle which is greater than 180. In the fourth quadrant, your phi is negative, and there it is 360 degrees plus phi. But because your phi is negative, you end up having an angle which is less than 360 degrees. Is that clear?
Okay. Yes, thank you, sir.
Okay, that's good.
It was a bit confusing for me.
Sorry?
It was just a bit confusing for me, but now I get the point.
Okay, that's good. Which means, yeah. Okay, so question number 3 is done. I'll upload this to Moodle, and also I'll try to. I didn't have time to upload the video for yesterday. So first I'll try to upload the video for yesterday, then I'll upload this PDF to Moodle, then I'll try to upload the video for today. Because tomorrow we are not meeting. Tomorrow I'm giving out the test to your friends, the third years. So tomorrow we're not meeting. But the invitation I sent you is for today and tomorrow. So basically now we are covered Monday evening, Tuesday in the morning, Wednesday in the evening, Thursday in the evening, then Friday in the evening. 1 hour, 1 hour, 1 hour. Don't underestimate the 1 hour. It's quite a lot actually, because at least you understand something. If you can finish a question in 1 hour or 2 questions, then that's fine. Okay. So I'll see you next week. So which means by next week we should be able to finish this story sheet and start story sheet number 2. Is that clear?
Yes.
Yeah.
So when are we having our physics quiz? And what topic is it on?
I don't know. You keep on checking on Moodle. You see if there's a quiz there. Okay.
Okay.
All right. So let me stop the recording.